This is John Gilroy from the Constellations Podcast. In the next 30 minutes, we will define optical satellite technology and how a LEO constellation can evolve into a true data network. Hit the music, Claude.
Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. With billions of new devices coming online, satellite and network connectivity will become increasingly more complex and our expectations more demanding. Today, we will look at what it will take to enable the new connectivity of the future. And to lead us on that journey, our guests today are Rivada Space Network's Chief Program Officer, Clemens Kaiser, and Chief Commercial Officer, Ronald Vanderbregen. We will discuss the growth of optical satellite technology and what it means for satellite data networks, optical intra-satellite links, and how a LEO constellation evolves into a true data network. Okay, Clemens and Ronald, we're going to jump right in here. Constellations, we've had a couple of previous guests discussing optical or laser communications, so I'm looking forward to hearing your views on it. But first, please explain a term that I assume will pop up a lot in this conversation, free space optics when applied to satellites. So Clemens, can you maybe unpack that difficult phrase?
Yes, thanks, John. And thanks for inviting us here to your marvelous podcast. Yeah, free space optics means really break the barrier, let the optics, would say, the light out of the cage. And free space optics means really without any kind of carrier, because in compared to optics on ground in terrestrial networks, light is in the fiber, so to say, in the glass fiber cable. And the free space optic simply means we don't nothing else than only a laser beam, which is connecting 2 points in space to each other.
There's a consulting company called McKinsey, and everyone gets numbers from them all the time. And according to them, 60 to 70% of space company funding is now directed at low Earth orbit ventures. So can the potential of LEO be unlocked for data network services, Ronald? What do you think?
Obviously, the answer is yes, John. And again, thank you for having us here. Really, really looking forward to this. Obviously, the answer is yes. 60 to 70% is quite a lot. So I think we also need to reflect on that number. When 5-6 years ago, I was at the satellite show and you said you were involved in LEO, people were wishing you good luck in a way that made you think twice as to, what do you mean by that? And when you got the question and somebody was asking, do you think that GEO ultimately will be replaced by LEO? And you would say, well, of course, it's just a matter of whether it be 10 years or 20 years or 50 years. 0% of people would agree with you. Whereas now, I think also 60 to 70% are saying, there actually might be something there. So it's already happening today. That's basically what I'm saying. And so what we're looking to do with our constellation is to even go beyond the ways in which we're currently unlocking that potential, which is more about, reaching far and difficult places that have no connectivity or are in distress, as we've seen with Ukraine, and to make sure that they get access to basically the rest of the world. And so that business objective is to pick up that data and get it down as fast as possible into a gateway, making sure it can travel the rest of the Earth's cables. Whereas our objective will be to keep the data in our constellations for as long as possible and carry it from the very beginning to the very end, because we believe, and we have seen, and in our discussions with customers, we've noted that that opens up a lot new business opportunities for data networks, and we're very much focusing on that beyond what's already happening today. So it's an absolute and definite yes.
I'm glad you opened up with a few years ago, they raised your eye at talking about LEO. But let me tell you something, that last question I asked you, 5 years ago, if I would have said data network services, that would have been a really eye-raising question. It would have been, what are you talking about? So things have just, we're in this big tsunami change here. It's just hard to keep up what's going on. Clemens,
yeah.
What impact, if any, will that all this new type of communication have on LEO satellites? Architecture and design, manufacturing, network management. How is all this light going to affect it?
Yeah, this is really a new era here. We are entering into a complete new way of how data will be transported in space and from any point on Earth to any point on Earth. I mean, the LEO compared to GEO simply means we are closer to the Earth's surface. And we can, and this is physics. Yeah? So a lot of people are always laughing at me, the non-technicians, when I come to say to lawyers or when I raise a hand and the finger said, this is physics now. So the link in the atmosphere from space to ground is the RF part. And the closer you are, so means 1,000 kilometers or even lower. Yeah. Obviously, they're much less distance than from GEO, which is 36,000 kilometers away. Means the throughput can be much, much higher. Yeah? So means the distance is shorter. Yeah? You can, with the same level of power, really push and pull a lot of more data to ground. So we will always have this RF link. And now the question is, what do we do in between these satellites? And the new way of doing it's really creating now a mesh on a very abstract level. And this is how we do it now in the radar. I tell the people, look, we have an IT network in the sky, nothing else. Forget the satellites. They are routers in the sky. They are managing the traffic. And the customers wants from one point to another point on Earth, get a connection, a service. Yeah. And this is at the end using network protocols, and the satellites and the respective brain on ground is able to manage all that. And here the optical links, of course, help. And this is new. This is different to the, I would say, first generation constellations we have with OneWeb and Starlink. Done a tremendous work. We learn a lot from them, but they were, I would say, based on the fact that they need gateways and they cannot interconnect between each other. So, and this optical mesh allows plenty of new opportunities of services for customers which even don't know what they can do with such kind of a backbone in the sky.
10 years ago, a company like Brocade talked about a data fabric, and that's increasingly being used. But I think your description of this, an optical mesh, finally, it gets so complicated. I think I understand what's going on. It's a mesh that's going to make things more productive and efficient for everyone, I think, here too.
Yeah, exactly. You see there, we have even discussions that people want to add. And what is about edge computing? What is about cloud in the sky? So with this mesh, not maybe with our first generation, but if you add this kind of functionality, you I would say lift, so to say, critical infrastructure from ground into space, because we see currently with all what's happening on ground, I would say in this crisis situation, here, especially in Europe, how vulnerable our terrestrial infrastructures are. So there is a trend to go into space with, I would say, I do not say that it's not at all, I would say, riskless, but at least, I would say, an alternative to make things safer by putting them up into space and connect them via light.
I want to talk about convergence, and I have a question that maybe both of you can jump in on. The convergence of satellite and wireless has been a long time coming. So what are the optimal architecture, hardware, and software requirements for a LEO constellation to become what's called a true data network? Ronald, you want to jump in on this, and maybe we'll toss to Clemens?
Sure. So but when you talk convergence, I think ultimately, and I think Clemens explained it really well, what we're trying to do here is we're basically putting a terrestrial network in space. So it's not so much about convergence. It's more about the integration of hardware, software, components that will basically make that satellite system, if you want, act and operate like a terrestrial network. So that for me is key. Again, it's not so much about convergence. It's about mimicking what we do in space, or is mimicking the terrestrial infrastructure that we have on the ground in space. This is, I think, what drives convergence or integration or interoperability, whatever you want to call it. And the better we do that, the better we can integrate it with terrestrial systems, and the more we can make benefit, or we can benefit from the unique traits and characteristics of each system. Because sometimes solutions are just better put in space than they are able to perform on the ground. And so that's what we are in the process of doing. And again, speaking to our customers, they see a real need for that. Because again, certain things are just better up in space than they are on the ground.
So Clemens, what word are we going to use here? We're going to use interoperable, convergence, or orchestration? What are we going to use here?
Yeah, exactly. I know we are talking. The point is a bit, and I'm coming really from the space world, the point is, if you lift a satellite up into the sky, it's no longer accessible. So the point is that these satellites, of course, in contrast to ground space-based infrastructure where you can anytime go there and do the respective maintenance. Yeah, you cannot do this in space. This means the trend in the space now is about software-defined radios, software-defined networks. Means we have now implemented into our satellite the brain, the possibility to be upgraded. So the challenge is to put the right hardware on board and be flexible on the software to put also at a later stage and to upgrade software to the customer needs, to the needs of our growing network. Yeah? And I think this is the key. So you need something which can live and can be evolve also in the sky, that this network can be maintained thoroughly and upgraded according to the needs. Yeah. And at the end, I love the word orchestration. Yeah. It's really an orchestration of plenty of things. It's quite complex, to be honest. I love complexity, to be honest. It's orchestration of these resources you have, of this network in the sky, that really the customers get the maximum quality of their services in terms of reliability, availability, latency, and God knows what they have, also in terms of security. And this all needs to be done in a clever way. And this is at the end really like an orchestra. You have we have 600 routers in the sky. So this needs to be orchestrated indeed.
Raul, I got a question for you. I live in the Washington, D.C. area. Of course, security is on everyone's mind. You drive around the Beltway, you drive around the Pentagon, security, everyone's thinking about it. So I would think that an ultra-secure network is the holy grail for global enterprise and government communications. So is our friend here is laser technology the key to providing ultra-secure connectivity? Is that the magic sauce?
It can be part of it. I think what is key is that it is a truly global network. That is the key. In today's world, if you want to bring one piece of data from one place to another, and you go to a global operator, let's say we do BT or AT&T, that claim to be global, then the reality is you hand it off to one of their third parties who's in the metropolitan area running a metropolitan fiber system. And before that, there may even be a local tail provider. Then you hop onto the network in question of BT or AT&T, and then you may go across the ocean, and then you go through a global crossing network. And then on the other side of the ocean, there's other third parties that may carry your traffic into other metropolitan areas, into other local exchanges. And so before you know it, this global network that we thought we were writing is basically consisting of, multiple pieces and patches that come together at various patch panels in various locations that can be hit, that can be targeted, where people can put their listening devices into, and not even to begin mentioning how cables can be cut with people putting shovels in the sand and what have you. So to really have an ultra secure network, the key is to be able to be the one provider that really picks up the traffic from the very beginning and really carries it all the way to the end, because now that comes with the capabilities to not just in our case offer lower latency and offer real security because it's one single network, but you can also be much more firm and strict in your SLAs because you are in control of this very network from the very beginning to the very end, something that any terrestrial operator will never be able to be. And if that comes with the same performance, or in our cases sometimes better performance than anything terrestrial, then I think that is the key to a true ultra secure network. And lasers are an important part of that. I think Clemens explained that. That's just that. It's a part of what ultimately is the key, and that is the being completely global.
Yeah. Clemens, true confession here. I've been married for 40 years. And I remember when we first got married, I turned to Jan and I said, well, this summer, do you want to go to the beach or want to go to the mountains? She said, I want to go to both. I said, well, I can't afford both. You got to one or the other. And this was, typical young married couple. We work things out somehow or other. Now let's apply this to your world. Do you see the growth of satellite data networking services eating into the growth of Earth observation? Are there enough financial and technical resources to support the growth of each one? In other words, mountains and beach vacation?
Yeah, I'm coming originally from Earth observation, to be honest. And this is quite fascinating for me now, working in the telecommunications part of the space business. Yeah. And I know how huge the demands is of this. And I worked at EUMETSAT, really these monster satellites, Meteosat, EPSS-G, the Copernicus satellites. They are producing a hell amount of raw data, with their huge instruments. And the bottleneck is their RF link. Is simply their RF link. So a lot of data compression, a lot of stuff is doing on board to really get over the poles downlink to a ground station of this data once every 45 minutes or even 90 minutes if we have only one station. So with optical links, it's completely It's completely a new world for them. And we got already requests from people who wants to plan the new way of new Earth observation satellites and say, hey, the bottleneck for us remains the downlink. We have plenty of data, plenty of pictures we record. How to get it down? Can we interconnect with your network with an optical laser, and you take care that these data go down to the respective, I would say, ground segment of our customer? Yeah. And this is exactly what it means. The beauty is now that our mesh can be opened and other elements can be added to this mesh. It can be a geostationary satellite. So it's also other planes, so to say, can be interconnected, not only on telecommunication, but also customers like Earth observation satellite. And here I see a clear, I would say, win-win situation for both. Yeah. It would be a huge, I would say, step forward on Earth observation if there is no more a limit in the data a satellite can record over an orbit, because he can permanently download this data. Otherwise, he has simply to wait. He is limited for an orbit maybe to 20 minutes. And then I would say the buffer is full, the data is completed, and he first needs to bump down the data. So therefore, I do not see here any kind of limitation or eating the one or the other domain. I see here a constant growth, and I think Earth observation will even benefit from this new architecture and infrastructure in the sky.
The Constellations podcast was launched back in 2017. It was a small step for man, but a giant leap for podcasting. Today, thousands of people from all over the world listen to Constellations, and thanks to you, we've grown into more than just a podcast. Sign up for the Constellations newsletter to receive articles on current industry issues, podcast summaries, and contributed blog posts at constellationspodcast.com. Ronald, if we looked at a transcript of this conversation, data networks and data pop up constantly here, I'm sure. Let's maybe switch gears a little bit. So in addition to data networks, what other new opportunities are there for new end user services? Will they require a new business model?
No, I don't think they require a new business model. So speaking of business models, I look at it in the sense of like a value chain, right? I mean, you got the operator, in this case, a satellite operator, data network operator. You got, resellers who have the relationship with the end user, who really require certain applications to be built, for which components need to be bought, for which, operating services of companies like us need to be bought and all that. And they put that together for the end user. That model will continue to exist. As a matter of fact, these resellers who left, right, and center have been bypassed by some of these operators who, wanted to go directly to the end user and were effectively competing with their customers, so to speak, right? I mean, as a satellite operator, we've seen multiple examples of them bypassing resellers, going straight to the end user, leaving the resellers high and dry, like, what are you doing here? That was all based on the fact that the services that they were offering in geo, that's pretty obvious, were pretty, how shall we say, similar. And that if you buy it from the one or the other, it really doesn't matter that much. The satellite might be like 2 degrees to the left, 2 degrees to the east or the west, but the services themselves are pretty similar. And so therefore, to have that direct end user relationship became really important for the satellite operator, because the services themselves were not unique. Us having the unique services that we have, that we've talked about, we don't have that need to, really in touch with the end user, other than, inviting them for shows and talking to them at shows and all that. But for the solutions to be actually offered, we will continue to go through these resellers and be very confident that they're going to be able to close that business with them. And they, in turn, don't need to be afraid that we're going to go around them because of the uniqueness of our services. So in terms of the business model, nothing is going to change other than, we're going to basically reinstall it into its purest form and not go around things anymore, because of these new applications that we can ultimately go after. And one great example that we're working with various resellers is, for instance, enterprise networking with SD-WAN. That's often talked about nowadays as being part of the future of networking. It will allow any enterprise to basically make a decision as to what network will we use for certain traffic to be routed. So if you have lots of employees doing lots of let's say internet stuff in the category of not really requiring security, then clearly you can use cheap infrastructure for that, i.e. the internet itself, broadband modems and what have you. You pay $100 a month and then you have so many megabits. Or you have data that, you need to keep ultra secure and, God forbid it goes to some kind of public place, because if the competition or anybody else would be able to get their hands on it, that would be a bad thing. And for that, you wanted to go on a very different network. And that could be, the Rivada network that will be super secure, like we talked about earlier. So SD-WAN facilitating enterprises to use one network, one type of network, another type of network, actually brings a lot of business that go well beyond any of the predictions that we have in the satellite industry about what the future market will look like, because that's basically only talking about internet access and last mile type of applications. This is a whole world that we're currently not tapping into as an industry, and that's that's a multi-billion, probably even more than that, industry of which we are more than able to take 1 or 2% of that ultra secure traffic and stick it onto our network. And that's completely outside of any prediction that anybody is making for the satellite industry in terms of our market. And so we're very excited about being able to work with our resellers and giving them an opportunity to tap into whole new businesses and whole new applications. And these are exciting discussions that we have with them, because this is exactly what people are looking for. Something new that's a real solution for real companies that have real problems and have real money to solve those problems. And that's a much nicer discussion to have than, can you please connect this last site for me? Oh, and by the way, it needs to be less than $100 per Mac per month, because, otherwise I go to somebody else. Yeah. So very excited about the opportunities that we have there, but it's exactly the same business model, but we're sticking it to more rigorously than ever before, I guess, because of the uniqueness of the service that we have.
I'm thinking all the marketing people over the world are going crazy now because of the total addressable market, the TAM. How do you define it? I mean, Ronald may define it one way, Clemens may define it another. It's very difficult, and I think that's a challenge people have in all kinds of innovative technologies that are out there. No one really knows what the potential is. Clemens, we're going to talk about the ESA, the European Space Agency.
Yes.
What I've read, they expect that optical transmission could take on the burden of handling increasingly high bandwidth traffic, replacing RF as the primary means of sending and receiving data from satellites. So in this scenario, what would be the role of that? Is it left out? What happens to poor old RF?
Yeah, poor RF. No, again, I'm sorry to say to my dear friends of ESA, there's again physics. I mean, if I look out of the window, we have a quite cloudy day today. Is that snowfall even? Do you see sunlight? You don't see the sun. So the same problem with optics. If you have an optical link spearing down, so to say, to the Earth, and you have massive clouds, nothing arrives the surface. So RF goes through the clouds. And this is a big, I would say, advantage. We see it in applications like radar satellites, but we see it also on the communication side. So unfortunately, my dear friends of ESA also simply have to respect physics. And there will always be room for, I would say, the RF. Think about the famous hotspots. We have also, I would say, headaches, which is, for example, Singapore, where we have permanently rain, permanently high density. So also here, how to go with optics for this kind of atmosphere. And therefore, you are, so to say, in terms of optical links, maybe then you go to places where you have quite nice climate, dry weather and so on, which is, for example, in southern Greenland, as we learned recently, or in other places on the Earth. So means you are a bit limited to certain locations, and have to respect the weather. And it's the same way in both directions. And by the way, from ground to space, it's even more severe because you have simply the atmosphere already at the, I would say, exit of your laser, and it's or scattering the laser beam. So here is a lot of work still to be done. From space to ground, I see a high possibility, especially with respect to Earth observation, as we said before. Ground to space with optics, still some homework to be done. Very powerful lasers needed. There are people working on that. Therefore, RF remains, and I'm pretty sure that it's I would say, in a complementary way, both technologies will stay alive and find their way thanks to physics.
Well, Clemens, if anything comes out of this discussion today, I think we have a new T-shirt. You gotta respect physics. That's the T-shirt I'm going to wear.
Please,
you can't run away. You can't run away from it. You got to respect physics. Yeah. That's our motto here. Ronald, from mottos to something serious here. So a constellation like the one Rivada is putting together will incorporate optical intra and inter-satellite links. So could you give us maybe a brief definition of what those are and what that really means for our customers?
So like I said, they are interconnecting the satellites, forming an optical backbone in space. So they are a means to get the data from one satellite to another, such that we can indeed close the link in space between any 2 points on Earth. So that for me is critical. Cheekily, I would say, as much as I really like it being optical, because it comes with a lot of capacity. Had it been RF with the same type of capacity, obviously that would need a lot more power. But that would not be the end of the world, because it's not the optics, it's not the optical link that defines the system that we have. It is what we run on top of it. So, like I said, we're running a network in space, so we have a proper network protocol run on top of these optical inter-satellite links. So where you can connect any two computers with a USB cable, or you can connect them to a local area network. They're both connected, but the way they will operate with each other and the capabilities that you have towards one another are very different using the one system or the other, and that's defined by the network protocol that you run over it. And so that I think is key. The optical link is important because it provides the infrastructure, and it basically makes the architecture. But it's the network protocol that we're going to be able to run over it that really determines how we're going to be, different and unique relative to all the other systems that may or may not be using inter-satellite links, as some of them already do. But typically, that's then being put in place to again get the traffic as quickly as can to a gateway. And sometimes you want to use an inter-satellite link to basically increase the distance that you can go from the point where you pick up the traffic to the gateway where you want to basically pump the traffic into. So optical satellite links, really important, but not the key definer of why our system is different relative to others also using optical satellite links. Does that make sense?
Yep. Yeah. So Clemens, we're going to talk about these optical inter-satellite links. It looks like they'll require one moving satellite to point a laser beam at another moving satellite. Now, what could possibly go wrong? All the T-shirts in the world is not going to solve that problem. Maybe all the mathematicians in the world can't solve that problem. So do you use some kind of alchemy, or how do you make all this happen?
Yeah. It's absolutely clear. I do some lectures here in the University for Applied Sciences in Munich, here in Germany, and it's orbital mechanics. Yeah, and then if you speak about the velocities in space, the people fall from the chair and say, "The bloody hell, this is quite fast." Yeah, yes, It's true. Otherwise, you would fall down to Earth. So, how to interconnect now between two satellites with that level of speed? Well, the good news is that our constellations are all moving in the same direction, and neighbor satellites, especially on the same plane, are even moving with the same velocity. Means, relatively to each other, satellites have not such a high, I would say, delta speed. Yeah, we have only the challenge that over the poles, so to say, the planes are crossing, and then I would say you have to swap to the laser link. And we have one famous seam, we call it seam, where you have one plane where the, I would say, satellites are moving in counter direction. This is the really technical challenge where the laser link, and we can close this, has a very high relative velocity. Meanwhile, the technology is there to close it. Yeah. And if once a link is closed, it is stable fantastically. So the providers have really worked on technologies that if they once found it, so if once the two heads found themselves, even over distances over 7,000 kilometers, they stay close, even with micro vibration, what little tumbling satellites are doing. Yeah. The question is how to find themselves. So the strategy to find the other, I would say, the counterpart, it's a bit tricky, but you know where they are. We know the exact position thanks to GPS and navigations. But there's a kind of a strategy in spiraling the links, and then they meet, and then they close, and then it's a closed loop control system which keeps the thing alive. So a lot of things has done thanks to, and I must say this, I'm a bit proud to be a German, because we have really 2 companies in Germany spearheading here this technology. Others are coming in the US, in Japan, is all here. But I see here a lot of things has done compared to really years before. And we are there now to take really mature technology on board. It's really off the shelf what we can do. And this is a big relief for us, that we not have any technology development. We really can take it from the shelf and put it on our satellite and it will work. Yeah.
For Clemens and Ronald, I got a jump ball for you. I got a question. You can jump in. Either one of you can take it. We've discussed the impact of optical communications will have on LEO constellations, but what will be the impact on ground stations? And these are undergoing some significant transformation themselves as they migrate to a more virtualized environment. So who wants to grab that one?
Well, so ground stations indeed are in the midst of all this, and I think they have a fantastic opportunity already today with all the bent-pipe LEO constellations that we're seeing requiring more and more ground stations, and so that's, I think, a fantastic opportunity that they're currently benefiting from. But typically a ground station, teleport, gateway, whatever you want to call it, it's a building and they have a bunch of acres of land in front of the building and there's a bunch of antennas there, and that's the business model. And with our type of infrastructure, we see them as great resellers, because soon those couple of acres of land in front of their building, they will be able to go well beyond that, because there's multiple businesses and government agencies and all that in the typical territory of like 200-300 mile radius around these teleports, where if people want to make use of the system that we're going to be putting in place for those secure traffic that we talked about earlier and low latency stuff, then they will need antennas in more places than just on the couple of acres in front of the teleport. And so I see a great opportunity for them to go out and manage antennas in a larger area and be a great partner for us and able to tap into a whole new revenue stream with enterprises and agencies that they had not access to before, simply as a function of putting a terrestrial network in space. So we have great expectations for the teleport market, both already today for the existing constellations, and even more so with what we're going to be putting in place, allowing them to go beyond where they are today, both in terms of business opportunity as well as the geography, so to speak.
Crystal ball time. We're going to first go to Clemens and toss to Ron. So Clemens, 5 years from now, what will be the driving force for data network services in regards to optical systems? What do you think is going to happen in 5 years?
Yeah, we are discussing currently with the optical intra-satellite link providers really the future of really throughput of this system. So we in our satellites are using now 10 gigabit per second throughput for optical links. The future, the next step is coming soon, 100 gigabit per second. 100 gigabit per second throughput via an optical laser link. I mean, okay, we have always the limitation with the RF. We spoke about this. There are physical limits, but in between a satellite or in space, you can really connect with more or less, I would say, open-ended throughputs. So this will support. This capability of 100 gigabits will support massively to increase infrastructure in space. Because if you have unlimited, I would say, resources to connect, then you can also add, I would say, storage, data processing, edge computing, I would say, in the sky. This will come because, so to say, the big cable in the sky, the optical link is more or less open to even higher throughput. And I think this will drive a lot. So therefore, this evolution in the optical link will again allow complete new application of data handling, storage, processing in the sky. And I think in 5 years from now, I see maybe it's already standard, but the products are under development. We saw it already, and it may quite likely be that we are in a complete new world of higher data also in space.
Ronald, we have a record here. I think we have a number 2 T-shirt, Big Cable in the Sky. Maybe that's the one. Yes. Your students might like that. So Ronald, big cable, in 5 years, there'll be a big cable in the sky. So what do you see in 5 years?
Well, So I think there's been a lot of focus on optical. Let's also not forget what's going on the ground, guys. I mean, the antenna technology is super important to us, and the phased array technology is also going to be a great enabler of these space-based data networks. So my hopes are and beliefs are that 5 years from now, ideally, we'd like to have big and small phased array antenna systems that you can basically throw on the rooftop, power up, wait for 5 LEDs to turn green, put in an Ethernet cable, and boom, you're up and running. I think that's the future. That's the kind of user friendliness that we need to go to. So if we get that all in place in combination with the big pipes in the sky, then I think we're going to be able to solve a lot of problems for multiple companies and government agencies in terms of cybercrime, latency, running huge ERP applications globally. All that will be made possible by terrestrial networks in space that we're putting together. So I think we're looking at a bright future here for this type of technology, both in space as well as on the ground.
Clemens and Ronald, you certainly have opened up the world of optical communications to our audience. I'd like to thank our guests, Rivada Space Network's Chief Program Officer, Clemens Kaiser, and Chief Commercial Officer, Ronald van der Bregen. Thank you, gentlemen.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.